Yo, 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 and welcome back to this shit show. Good morning, Harukanan. So, new week. I'm just gonna start by going through what we did last week and what we have been doing these last couple of weeks. And we're on a little bit of an adventure, to say the least. Terrain adventure. Don't have That's pretty much how I see this, but it's experimental. What's up, Toffai? I'm doing fine. I'm ready for this new week, and hopefully we will start producing some interesting stuff. So let me go through this. So basically what we're doing is, from a macro perspective, we're developing a creature collecting game. Micro perspective, right now we're working on the terrain part of the game. And the idea is that the playable character has this garden he or she takes care of. And depending on how he or she takes care of the garden, creatures will come and live there. And one of the gameplay elements will be the terraforming of the terrain. So heightening and lowering the terrain, lowering it enough will spawn water and such, and you will also be able to plant trees, tall grass, small grass, etc, etc. And we're currently working on the terraforming part, like hiring and lowering the terrain. And since we want to support this like in real time and want to be able to do it a lot, we need to support like very efficient terraforming, basically. So with that in mind, and the fact that I like to explore already solved stuff, I suppose, and implement them myself, we tried to implement a terrain system. And currently we have 3 versions of it. We have one that I like to refer to as the naive one, and it's basically consists of one base object, the terrain base, and then multiple terrain patches. Actually, all of them do. What makes this one naive is that it relies on monobehavior objects. It uses mesh filters and mesh renderers and mesh colliders. And to be honest, let's take a look here. I don't know exactly where we left off, so we might have some components that disturbs us. Let's see. Ground collision checker. We don't do this anymore. Great. So entity is grounded. Okay, great. So this is the naive approach. What setting do we have? 512 times 512 meters, the same vertex count. So we basically have 4 times 4 patches, where each patch is, what is it? 64 times 64 maybe? No, 128 times 128. What's up, Robert Pattinson? So you're planning your game to be good looking, performant, and fun. Yes, sir. Don't we all? What's up, Geralt, and good morning. Thank you so much for the Prime. Really appreciate it. brightening up this Monday morning a bit. So, this is the naive approach, and like, to be honest, we haven't really gotten to terraforming yet, but okay, we have some weird collision going on. That's for sure. This is not really what I anticipated. You make my days more enjoyable. I learn from challenges while I work from home. Beautiful, that's how I want it to be. Yeah, this is a little bit the opposite of majestic. So let's see. I don't know why we're getting this. Okay, let's start today off by fixing the problems we left on Friday. I guess. So animate entity. Where do we have you? Playable entity. I don't know about this. Don't we have... Okay. So, ground collision checker. This is a component created to work with collision with height maps and height maps only. And I thought we weren't relying on this one anymore, but maybe we are. Ground collision checker. We do add it, but we don't use it. Then we use this one.
Yeah.
Terrain base, terrain patch. Mesh collider, shared mesh, yeah.
Yeah.
Okay, I think I know. Character use gravity. So that little thing. Okay, so this is terrain with a mesh collider, and it's a little bit janky when it comes to the movement, but like performance-wise, we haven't really done any optimizations and stuff like that, but performance-wise, it's pretty damn good, isn't it? I'm still shocked. Gravity will help indeed, yeah. Although, like, I am a little bit worried how this one would perform. Like when we do terraforming, when we heighten or lower the terrain, we're gonna have to... The question is, do you have to regenerate the full mesh, or can you just alter... Yeah, I'm not entirely sure how that would work. Unity, mesh, alter mesh at run time. Little Miss Murder, what's up? I'm curious. Yeah, I'm listening. Are you going to cell shade the terrain as well? No, that is not the plan right now. We are going to do some stylized shading on it, but far from as, like, not as aggressive as we do on the character. Yeah, Little Miss Murder is a pretty nice name, actually. Nah, but the plan right now is to go the route of, you know, cel-shaded foreground objects, watercolored-ish background subjects. I'm thinking of having the distinction be things you can pick up will be cel-shaded, things you can't will not, basically. Are you going to outline it? No, that's like, so foreground objects will be outlined and have aggressive cel shading. Background object won't have neither of those. That's the plan, at least. Okay, let's see. Currently I have this code, but create a mesh, set it. Transform. Yeah, let's take a look at this one. All right, the character looks good. Thank you, appreciate it. I wonder which method specifically he referred to. And I also wonder, probably gonna have to write some like performance tests for this, like, because you want to find the best possible terrain setup to get the most performance. So how small should each terrain patch be? Like, if you want to edit them in real time, you want them to be small, right? That's something I think about as well. So, like, if the idea here with garden indirect and garden instanced are that they are rely more on the GPU side of things. or they make the GPU make most of the work, while the naive approach here makes the CPU do all of the work, basically. But let's say, for instance, that we change one of the vertices in here. Then we probably need to update the full mesh. And if we... And then we're gonna have to recalculate the tangents, I suppose. Oh. Ooh. So is it this one we have to rely on? Wow, this is very cool. Okay. Robert Pattinson, you use jobs and ECS and dots. No, we're not really there just yet. Have you done any work with ECS and dots, Robert Pattinson? Little Miss Murder. Anyway, murder is a collective known to. I love that. Is it for crows? Crows, I think. So, allocate writable mesh data, apply and dispose writable mesh data. Okay, so is it something like this? So, like, if we want to start today with implementing terrain terraforming on the naive approach, the CPU space one, is it these methods we want to rely on? But yeah, probably. No. Man, I wish my day job was making games. Yeah, that would be pretty cool. I'm working on a super exciting mobile speed radar app. That sounds nice as well. You think? Mobile speed radar app. What? I don't really understand exactly what that is. I hate mobile dev. Yeah, I partly agree with that statement. I do. If I'm gonna be honest, like, I get it. Okay, so this one implies that you don't do it on the main thread. Well, basically there is a static microcontroller, question mark, running inside a housing that contains a camera and radar device. I don't know, doesn't sound too bad to me. I'm gonna take your word for it. I don't know. Let's see. What did we have? 1.2 basics. Oh no, did the 112? I'm gonna have to look into that later on. Let's see. I probably don't want to do this, but more like this. Whoa, 2000 triangles that need their position updated each frame. They follow a spline that is computed on CPU. Okay. Mark dynamic method on it. Okay, mark dynamic is probably, we probably don't want to do that because we're not gonna change it every frame. Frequent updates, that's vague. Which are more efficient when mesh data changes often. Like, this is vague. Modify the mesh object. It is a reference type, so any change you make will be reflected by the object which owns the mesh. Yes. But we basically just want to change the height of the vertices. So we might actually... That might be more straightforward than I first thought. Okay. Yeah, this one is what worries me the most as well. Although, if we don't rely on recalculate normals, it will be okay. But then again, like calculate normal from height, we have this one here, which is pretty good. And we have this and index wrapped, which we can rely on. Like, probably want to avoid this one. Maybe we can do this CPU approach. We can probably make it pretty damn optimized. And maybe it will be enough for what we need it for. So we want to avoid mesh. Let's see here, mesh dot recalculate bounds. We set the triangles here, so we don't really need to do this actually here. But let's see here. Create own methods to calculate both tangents and bounds. So what I'm thinking is mesh recalculate tangents, mesh recalculate bounds. Probably does it for the full mesh, pretty sure. We just want to change certain places of the mesh. So like, let's say that we heighten a set of vertices in the middle of the mesh, then we just want to change the Y position of those vertices, and then we want to recalculate the normals of those vertices and their neighboring vertices. We also want to calculate the tangents. And when it comes to recalculate the bounds, I don't know if we want to recalculate the bounds every time we change it. Like, we might just calculate the bounds when we generate the mesh, and then so that's when we calculate them based on worst case scenario, or how big and how low the terrain can be. Terrain patch. The size in X and Y direction is going to be the same always, but the height might differ. So we can just create a bounds that is the width and height, width and depth, and that has the max height minus min height as a Y bounds, I think. Maybe. I want to try it at least. Like, if we could get this terrain to work, it would be pretty damn nice. But then again, like, the resolution maybe isn't the best, but like the collision with the character, I don't know if it's good or... Nah, it's good. Rockadoodle, you clearly have some sort of European accent. Yes, I do. I'm from Sweden. North of Europe. Yeah. I guess Finnish, they have a pretty... There's quite a difference between Finnish and Swedish accent, I think. But yeah, I'm also extremely bad at hearing accents, so maybe I shouldn't. I just have so many thoughts in my mind right now, like how I want to approach this. Like, okay, I think I've been a little bit nervous before today's stream, actually, because I didn't really have a clear plan. But I'm starting to think that I want to implement... I want to get all the basic functionality working with the naive approach, because that one is the most straightforward. It's the one where I can rely on Unity functionality that I know and love the most. Like, this approach doesn't force me to implement my own height map collision system. So I think that's what we're gonna do. So pretty much let's take up this task here and add some implement simple terrain generation. Yeah, we're gonna do a custom shader here as well. So let's do but what I want to do here now, what we want to do today is, let's see here, manually calculate tangents, and manually calculate bounds. Thank you, Little Miss Murder, for the follow. Appreciate it. And when we have these two in place, that's when we can start. How do I want to implement this? Pretty excited for doing this, but let's see here. implement simple terrain terraforming. Fuck yeah, let's go. I've been waiting for this. We're gonna implement what's up, Cypher? Little Miss Murder, I will be dropping by every now and again to crack the whip. Sounds amazing. Appreciate it. Devil Hound, thank you so much for the Prime. Appreciate it. Cypher diggy diggy hole. That's exactly what we're gonna do today. I hope. Or actually, might be a bit too optimistic. Probably gonna get stuck on this manually calculating the tangents. But yeah, let's see. What we want to implement here then is... Okay, this is probably how we're gonna do it. Implement... what do I want to call it? Terraformer. Yeah, implement Terraformer component. And what we want to do with that one is implement or add raycast functionality. Resulting in a point on the terrain. Good luck, have fun. You too, Little Miss Murder, you too. And good luck. Good luck, have fun. I was about to say good luck with the radar stuff. Okay, let's see. Add raycast functionality resulting in a point on the terrain. So we want to, wherever the mouse is, mouse pointer, whatever you want to call it, pointer, we want to raycast and we want to get the intersection point on the terrain. And from that, we want to, from that point, we want to give it a radius. So add function for getting points within a radius of raycast collision point. Does that make any sense? Actually, we're gonna dive into this Terraformer component is actually going to be a action interaction, I think. Long time no see. Let's see how our interaction action system holds up. This one is okay. Add function for getting points within a radius of raycast collision point, pretty much, or add function in terrain patch Here's the thing we need to keep in mind. Like, worst case scenario, we click at the corner of one terrain patch, which means that we will actually alter 4 terrain patches. So you want to be able to handle that. Oh sh. So basically, when we do add raycast functionality resulting in a point on the terrain, we basically, when we click, then we want to do a sphere on that point, and we want to fetch all terrain patch objects we get. Ooh. We want to fetch all terrain patch objects, and then we want to alter them. But something to keep in... it should be okay, it should be okay. Like, all of these terrain patches, they have their own texture, height map, but the edges of each... What I'm trying to say is there might be a problem when it comes to... We might alter a point on the edges twice if we're not careful enough. So we might add double height to it, but or something like that. We'll see what happens. But so add raycast functionality resulting in a point on the terrain. Add overlap sphere call to get all terrain patches just affected. What's up, Meister K? Thank you, appreciate it. Hope you had a great weekend. Something like this. Add function in terrain patch for getting points within a radius of raycast collision point, and then alter affected points. What bothers me here is, or maybe it doesn't bother me, but like, we actually want to... When we alter these vertices, I think we actually want to change the height map and then recalculate the vertices and normals based on that height map. So we actually want to change it like with some texture. I don't know. Cypher 5 birthday question mark? Yes, it's actually my birthday today. No rest. Yeah, thank you. One step closer to what? Death? Thank you, appreciate it. I'm just celebrating it here with a cup of coffee and some terrain programming. One more nail in the coffin indeed. Thank you, Geralt, thank you. You said it, not me. You implied it. You implied something. Okay, let's see here. Add function, get input. Getting the points, actually for getting texture coordinates, 4 points, I would say. Alter affected pixels in height texture. And we need to remember as well that yes, this is a height texture, but it's probably going to be so much more. We're going to use it for navigation as well. And then we want to do, and then we do recalculate vertices, normals, and tangents. When I think about it, like manually calculating tangents, this one can't be that hard, right? We're gonna check. I'm gonna try and wing this. Just wing it. And we will compare what we get compared to the Unity approach. So yeah, it might be boring, but I think I want to start with this task, and then we can do this pretty easily, and then we can get to this one, the fun stuff. Okay, so let's pause this and do, what do we have? Debug shaders, world normal shader. Let's do world tangent shader. Boring stuff on your birthday, boo. Yeah, that's life. Hopefully, like, I'm going to regret this, but I just want to get this out of the way, and I think it won't take that much time, and then we can do the fun stuff. World tangent shader, tangent OS. Ooh, a little bit. The fuck is the... What is the fourth element of a tangent? Yeah. Jesus. Okay, let's be more specific. Tangent, HLSL. Fourth element. Okay. In Unity, the tangent is a 4-component vector, with the fourth component being 1 or minus. Yeah. Shit, I should have remembered this. I think I read it like 1 week ago. Or no, a month ago when we were doing the procedural grass shader. We actually read this. So what is it? 1 if it's right hand or something like that. Let's see. Let's just worry about the 3, so X, Y, and Z first, and then we'll see what we can do about the rest. So tangent world space. Actually, when we do... Okay, so it's just in object space we have 4. Then we change it to 3. Okay. So tangent world space. Debug. Okay, pretty. So let's add this one here and do regenerate. Okay, so these are the tangents generated by... This bothers me, so we're just gonna use the tileable texture. So let's see if we can reproduce this. Okay, let's put up GIMP and draw some stuff. I'm probably thinking about this like in a too simplified way. So if we do so when we calculate the normal for this point right here, we use a lot of vectors. So we do it by connected vertices. So it's this one, this one, this one, this one, this one, and this one. And you pretty much take this one, cross product with this one, plus this one, cross product with this one, and so on around. So that each vector are included in a cross product twice, and then you add all that together and normalize it. And thanks to the grid properties, you can simplify it to what we have here. And let's see here now. Now we're interested in the tangent. So you want 3 vectors that makes up the tangent space. So normal, tangent, binormal, and they should all be orthogonal to each other, right? Like when I think about this here, shouldn't it just be we take the point we're at and then we take the neighboring point here. So we take this point minus, or is it this point minus this point, and then we normalize it, and there we go. That's the tangent. That's what I'm gonna try anyway. So let's see. Calculate normal from height. Private vector 3. Calculate. We probably want to do it in here as well later on, so we can rely on So now when we do it in a separate method, we're gonna do 2 texture reads here for like, or we're gonna do 1 double texture read. We're gonna read this value twice instead of just using this value twice, but yeah. So basically float current, get terrain patch I j, height, get index wrapped. I don't really think we need to do that, but whatever, ij for this one. And then we do float right is equal to this one. It can't be this easy. Return is it right minus current dot normal? I thought we could do this, but maybe not. Oh, this is only floats. That's true. We need to I guess we could do, so this is only height, but it's height in the in which direction? In the Z. Where is it? In the X direction. So I wonder if we can just do or I'm very skeptical, but let's just test it. So recalculate tangents gives this. Okay, let's add a flag as well so we can test it. Test flag 1. So we're gonna do normals private. We also want to change it so that they are vector 4 as well, I think, but let's go with vector 3 for now. Tangents. It should be okay. And then we do IJ. Okay, and then we do if test flag, what was it called? Flag 1. Test flag 1. Oh, we don't have it in here. Oh, that's true. Ooh, generate unity calculate normals. Which one is this one? Terrain patch. fuck? Oh, we don't call it at all. Unity calculate normals. We call generate. Actually, we call generate here. Okay, let's do test flag 1. I thought. Oh, never mind. Here. Oh, test flag 1. There we go. So if let's rename it here as well. Test flag 1. So if test flag 1 else. So if test flag 1 we do mesh.tangents is equal to tangents. Our own very badly generated ones. Okay, let's change it to 4 now. I think this one is wrong. So between 1 or -1, and this one should be right-handed, I think. So I think it's a 1 here, but I don't know. Like, it feels like I'm winging a lot of stuff here. More specifically this one, but whatever. Mesh recalculate bounds. Okay, so if test flag 1 is true, we generate the tangents ourselves. Let's see how much I screwed this up. I like this color though. Okay, kind of fucked. So let's, before we try and simplify stuff, let's do this. So we do vector 3 current is equal to let's try and recreate the actual position of these. So it's or I guess we could do could just call this one actually. Maybe that's better. Get index wrapped. Yeah, so maybe we should just do this. Current is equal to get or actually, what is it? Vector. Yeah. And here we do get index wrapped ij. And here we do vector 3 right. The only problem here being that they are vector 3s, but I think it's okay. I plus 1 j. And then I wonder if we want to do return new vector 4. Another question mark here. So tangent float 4, the fourth component here is 1 if it's right-handed coordinate system, I think, or right-handed tangent, and -1 if it's left-handed, I guess. But this is excluding normalization or not. So what I wonder is this one normalized, or should this one be normalized with the fourth component in mind, or should we normalize the 3 first components by themselves and then just set the fourth one to 1 or -1? Let's try. I hope. I think we want to do it like this. Tangent is equal to current minus right. Might be the other way around. Normalized. So we do tangent.x, tangent.y, .z, and 1. Okay, let's see what this one results in then. Exciting, exciting. Okay. What did I screw up? At least the tangents on these strips here looks to be all right. I think. Yeah, I think they are. What the Okay. Ooh, private. Oh, yeah. Okay, I think, do we want to do... Wait, is this one actually... Get terrain patch height. Get index wrapped. A little bit perplexed here. Over this one being private. Because get terrain patch, this one can return neighboring terrain patches. Okay. Does this make any sense? Terrain patch. This one returns a terrain patch, and then we do vector on it. Not entirely sure this will solve anything, but let's see. Index was out. Okay. So something here is not entirely correct. Let's see. Get terrain patch. Index was out of bounds. I thought we... Terrain patch 50. This is the exact problem that this one was implemented to solve. So I don't really get... Yo, what's up, Cooler SK? Yeah, so did I. If x is bigger than resolution x, add 1 here. If it's less, -1. Same here. So we get the neighbor, okay? We need to celebrate. Yeah, that's what we're doing here. Doing some terraforming / terrain implementation. That's celebration, right? Appreciate it. What do you mean? This is party music. Can get index wrapped. Yeah, that's what we want to do as well. So yeah, I don't get why we're getting a problem here. Index out of bounds. This index should be wrapped, which means that we shouldn't be outside or inside or whatever. Okay, so I'm gonna be honest, I'm a little bit worried about, we state that this one is private here, and here we return terrain patches that are neighboring ones. But we can still call vector on them. Yeah, I must have screwed this up. Sounds more like going to bed music to me. Nah. This is chill index programming music. Okay, what I'm trying to get at here, at least, is how the fuck are we able to access this one from a neighboring terrain patch? Something is wrong, right? Or am I misunderstanding something? Get index wrapped. So if x is bigger than resolution x, then we do subtract resolution x. That's correct. I'm also a little bit, so this did not result in an error. This does. So it seems like this one is the culprit. Get index wrapped, vector. And yeah, okay, so in vector we do vertices. Yeah, okay, so we can't, yeah, okay, I think. Index was outside of the bounds of the array. That one's still boggles my mind though. Okay, I'm gonna open that one, but I don't think I can play it, you know, copyright. An original song from Dwarf Fortress OST. Okay, I'm gonna save this link. And then I'm gonna party to it by myself. Can't play game music on Twitch. What kind of tyrannical place you live in? I'm actually also simulcasting to YouTube. That is probably, that's what I'm most worried about. YouTube. Okay, nothing works as it's supposed to do here. I still don't understand how we're getting terrain patch. Okay, so look at this. Isn't this weird, or is it Monday morning brain? Let's take a look here. So current, we like, let's take this one then. Get terrain patch I plus 1 J. Okay. So Y is plus 1. So we have I, J is equal to 1 and 1. And then we do, so if Y is bigger than ooh. Yeah, this is correct, right? So if J is bigger than resolution, we add 1 to it, and then we get that neighbor. So when we return here, what we return here can be a terrain patch that is not this instance. So why are we able to do... Yeah, it's somewhat tyrannical, I suppose. Reflection, yeah, I don't get this at all. And also, one more thing I also noticed. So there's a lot of things now, but this one, we can't really do it like this because we're calculating tangent from height here, so we don't actually have the right one just yet. I don't think that is the problem, or is it? What if we did... I just want to try this. Oops. Okay, same problem. Okay, let's see what kind of init was outside the bounds. What do we have? 50. Can we do this? Actually, let's just debug it. So we're gonna change it to let's do this. Get vector. What's up, dev spies? Hope you had a wonderful stream. Let's return this. But I also want to do... You too, dev spies, you too. Yeah, let's just do it like this and see what we get. Oh yeah. Okay, now it makes sense. Okay, get vector. And let's regenerate this one. One zero was outside the bounds of the array. What? Yeah, let's take a look here. Yeah, okay. Terrain base. Yeah, okay. The fuck? How have we made this work? Okay, we have only relied on height previously. That's true. Okay, so that's what we want to do later on. Okay, now it makes sense. So the problem is when we do get terrain patch here, we get a neighboring terrain patch, and when we try to get a vector from it, it hasn't been instantiated yet. So it actually has a vertices array of length 0. So I guess if we want to try, like, the problem is that we rely on getting vertices instead of, like, this we can do from the get-go, because here we rely on it's still, yeah, here we rely on height maps, and neighboring patches has already get their height map set, so it's okay to read the height map of neighbors, but the neighbors might not have been generated yet. So basically what we want to do here is we don't want to get vector, we want to get height, and then we want to, like we did first, and then we want to recreate the vectors. So if we want to go this way in the future, we want to do something like this, but let's see. So we basically want to do vector3 current is equal to and we also want to do right is equal to new vector3. And let's see here now. XY. So in here we basically want to recalculate this, I think. And we want to take this. The only thing that we're interested in is the delta, I think. So do we have this one here? Yeah, I think we do. Delta. I think this is the only one we're interested in. So we're pretty much going to fake the positions here. So I think 0.0 we can actually write it like this. 0.0 F current 0.0. Fake it till you make it, indeed. And here we have X or I plus 1, so here we're actually going to add delta.x, and then we do right and 0.0 F. So we read current height, we read right height, and then we create some vertices like representing current and right, but they are not actually current and right, but in relation to each other it's the same, I think. Let's try it, see what we get. Just want to remove this one. Sorta right, but not really. And I do wonder, delta x right height, is it the direction or is it something else? Okay, great. It's close but no cigar. Okay, so now we're at the problem of trying to figure out exactly how Unity does this compared to us. But let's take a look at Mesh Unity. Tangent recalculate tangents, there we go. From the normals and texture coordinates. Unity calculates tangents using the vertex positions, normals, and the texture coordinates of the mesh. I would love to know how they do it. So right now we do it from vertex positions, texture coordinates. Maybe. I'm very interested in how they do it. Okay, theirs is a little bit smoother and less offset compared to ours. Okay, so I wonder if I want to do... Let's see here. We have a tiny bit of an offset here, so maybe... Could that be because we want to do... left, so if we read left height and we do minus delta and then we do right minus left here, will this give proper result? Okay, there's a tiny difference, but I don't think I cared too much about that. So this is Unity's result. This is ours. I think I'm okay with that. Where am I? This one does look a little bit smoother, the Unity one. And then, if we take a look at this, what are we actually doing here? Right minus left. We take this one minus this one. So it's 2 times delta x here, and it's right height minus left height. And then normalized. So could we do... We should be able to do, I don't even think we need multiple lines here. We should, so right minus left, right? So 2.0f times delta x, right height minus left height, and 0.0f. Tangent normalized. I'm a little bit worried about the difference between Unity's approach and our approach here. Why? What does it come from? Like, what is the cost of this? And if we keep it like this, I might just put down a note here, and like, it's so small, I don't really think we need to worry about it. Actually, or never mind. Or nah, I think it's okay. So if we calculate it like this, we rely on right height, left height for this one right here. We do already fetch right and left here, so we want to include, like, we want to merge these two methods so we don't do double texture reads and stuff like that. How can we do this in a nice way? Wow, I was extremely far off with this one. In fact, do I want to make a custom struct here? Like, do we want a struct that is... or do we want to return it as a pair? I don't know. Or do we just want to put it in here, basically? I want to keep, like, let's see, when we terraform this terrain later on as well, we're gonna change vertex, normal, and tangent. UV is not going to be changed, but like we could create a nice method, something like okay, so this is what we're gonna do. Gonna remove this. I'm just gonna commit this real quick, and then we're gonna merge this one, make it a bit more optimized. So, and both optimized and handy when we later on want to change the when we want to terraform stuff. So I think we're gonna do yeah, I think I know a nice way we can repackage this. What did I change in base, by the way? Did I delete something here? Okay. Okay. Add calculate tangent from height. What is it? Terrain patch. Yes, okay, so now we're gonna merge these, but before we do that, I just need to run AFK real quick, so be right back. Okay, back. Sorry about that. Search, thank you so much for follow, appreciate it. Okay, so what we're gonna do now is... It hurts me to do it, because it's going to make the code a little bit uglier, I suppose. I like the structure of this, but I definitely want to avoid doing this here and here. So what I want to do is we're going to create a method here which we will use during terraforming as well. So it's going to be private void we want to set vertex. Fuck, do I want to send in UV as well? UV is both something that the mesh has for texturing, right? But we also use it to set the vertex positions here. And like it's UV, you can see it as a coordinate system for the terrain patch, where the 0 0 at the left bottom point and 1 1 at the top right point, and we can actually use this later on when we terraform as well. So I do think we want to, for now we're gonna do private void generate vertex data at index, whatever. So here we work with an int index. Let's do it like this. Int I, int j, and then we want to send in UV as well, I think. And we're gonna move. We're gonna do all of this in here. Actually, what do we do? Yeah, we're gonna do this. It's a mess. So here we create an index using this method. But then we don't use that one here. We're gonna send this one in. So we want to create all of these. Yeah, we're probably gonna change this a lot. So we want to do this. So vertex, normal, and then tangent. But and now I'm also starting to think that we might, Like we might want to change these directly instead of creating our own lists like this. We just create a mesh, set the correct sizes, and then we do, so instead of doing this, we do, I don't even know if it is possible, mesh dot, yeah, so it's going to be mesh filter dot mesh. Can you do this? Tangents index is equal to, let's do, okay, beautiful, because then I think we're gonna do, okay, we're gonna do a lot of changes here. So generate, we start by doing mesh, new mesh, mesh index format based on vertices dot length, but we want to do it here. So int what do I want to call it? Mesh data length is equal to good morning, Ferda. Yeah, mesh data length resolution.x plus 1 times resolution.y plus 1, and then we do int triangle, actually mesh triangle length is equal to 6 times resolution.x times resolution.y. Then we create new mesh and we do mesh data length. If it's bigger than this, we change it. And then we want to instantiate all of these as well. So I think, what is it? Mesh.vertices equals to new vector 3. How is it you do this? Array dot create, let's search. I wish I have your discipline, man. Keep it up. Appreciate it, appreciate it. Fill array, or instantiate array with values, C#. Oh, it should be repeating or something, or default values. Maybe we could just do it like this. Yeah, so new vector 3 mesh data length. And then we want to do it for everything. So mesh, let's just copy this one. So we want it to, for the normals, we want it for the normals, the tangent the UVs and the triangles. Normals, tangents, UVs, UV, and triangles. And this one is going to be new int and then we're gonna skip these. We don't want to do anything of this right here. And we'll do mesh filter, mesh. Okay. I will be lurking for now. Good luck. Appreciate it. Enjoy the lurk. So we create the mesh here. We just fill it with default values. Maybe unoptimized, but generate will only happen once. And then we're going to call generate vertex data at index. And that's how we're going to fill all of the data. And we're going to do not vertices, normals, tangents, UVs. Instead, we're going to do... Actually, so that means that... I would like to do it like this. Let's see. So after we have created the mesh, we do mesh filter mesh equals to mesh collider shared mesh. The question is, I wonder how if Unity does something beneath the hood if every time we do mesh filter dot mesh dot vertices index is equal to vertex. I don't know. So this is pretty much the method we're gonna call when we do terraforming as well. And yeah, so terraforming is per vertex. It's going to include 6 texture reads, very simple calculations, and assignment. So the for loop here, when we actually create it, the mesh is going to be generate vertex data at index I, j, uv. And then we can skip this, and we can also skip where do we use these? Get vector. Okay, first of all, get vertex, and we're gonna do mesh dot mesh filter dot mesh dot vertices. Triangles. Oh yeah. So here I guess we want to do then again, like, I'm a little bit afraid that anytime we do a call like this, Unity does something to the mesh behind the scenes. I don't know. So yeah. Use, I just want to put in a note here about mark dynamic. Yeah, maybe we want to do that as well. Nice poker face. Hey, I actually blew some air out of my nose. I promise. Yeah, this one. Ah, beautiful. Okay. But I wonder if we want to use, maybe use I'm not sure about this, or equivalent. Okay, so now we can remove these. Generate vertex data at index based on height map. Okay, if this works, I want to move on to this one real quick. We don't need to recalculate the bounds, I don't think. Or we do need to recalculate the bounds, but we only need to do it once. So not down here. Regenerate. Okay, yeah, this worries me. The fuck? Like, even though this is true, it shouldn't take this long. Okay. Yeah, that's unfortunate. Did this change like a little bit worried about this one actually. So accessing, I want to see if it is as slow if we do it on awake. So delete all of these. World tangent. And then we don't generate it in the editor. Instead we do it so we don't do regenerate. Instead we do, okay, I removed that one, but let's do private void awake generate. I want to see if this weird behavior exists during runtime as well. 512. Tangent material. Let's try it. Do we have an endless loop? Like, I can't imagine. Subdivision. Resolution. Resolution. Very worried about this one. I'm just gonna let this one run real quick, so hopefully real quick, so I'll be right back while Unity does the work. Okay, back. Sorry about that. Peter Bay, thank you so much for follow. So, okay, in conclusion, you do want to avoid this. Definitely. It's weird. So let's do this. Let's open up Unity once again, or the project, and let's just alter this implementation a tiny bit. We wait with doing this until further down. But this makes me a little bit afraid. Like, how do we want to do, how are we supposed to do terraforming with this approach if this doesn't work? Garden. So let's just send in mesh here, and we do. I wouldn't be surprised if I somewhere by mistake created a infinite loop, but we'll see. So what we do is we send in mesh here, and then we take this and we do this down here. So create the mesh, create the vertices, normals, tangents, UV and triangle arrays with just default data, loop through this one, fill up the mesh, fill up the triangles of the mesh, assign the mesh filter mesh and the mesh collider mesh. Could it be yeah, I want to try this. Okay, what have I done? Okay, so it seems you want to avoid this as well. Okay. Mm-hmm. Okay. Mm-hmm. Index buffer. Okay. Okay, so maybe this is what we want to do. Especially later on, set vertex buffer data. Set vertex buffer data. Very cool. I like that we are going to have full control over the size of these. Example vertex. Yeah, okay. Set vertex buffer data. Okay, let's see. Before we try this one, however, I just want to double check one more thing with our current implementation. Like, if we choose to go with Set vertex buffer parameters. Okay, so we set it like this, and then later on we... Okay, here we create the layout and stuff again, and fill in vertex data here, and then we set it like this. 0, 0, what do we have? Data start, mesh buffer start, vertex count. And then we specify, this is beautiful. Why wouldn't you want to work with the data laid out like this from the start? Then again, very cool. Okay. So what I want to do here, what I want to try is... just want to revert everything back a bit. So we're gonna do this, and then we're gonna do this. I just want to see that everything still works. So we're gonna revert back to, do we have this? I wonder about the triangles, however. If we take a look at this, mesh, okay, triangles we still want to do like this probably. We just want to do them once and never again. Okay, so down here we do vertices, normals, tangents, UV. Okay, so now we don't do... Now we just set... We create the mesh and then we set them like we did previously. We just create them in a little bit of a different way. We send in a mesh here. We don't need to do that anymore. Okay, let's see if we can get this to run. One sec, just gonna look at this song name and add it to my list of possible songs for future videos. Let's see. There. Ah, already have it. Let's play. Jesus, what the fuck? What the hell is going on here? Yeah, environment controller. Yeah, I forgot about that one. Let's see. Environment controller. Let's disable that one. Character. We want gravity. Okay, let's see. And we have the normal material, I think. Okay, let's do garden 5 and a world tangent material. Is that so? Tangent, there we go. Was there anything else I wanted to change? I don't think so. What's up, Peach? How's the progress? I think it's pretty good. Slowly but surely moving forward. Okay, everything works as we wanted it to. I just want to add back this one so we have a little bit of a nicer terrain to work with. Okay. Yeah, beautiful bubblegum hills. I do actually like the shading of these of this terrain. I mean, it looks it looks a little bit watercolory, right? I vote for pink grass. Actually, that would be pretty cool. And actually, like, when I think about grass, I've always thought about grass like the grass we have in our world, you know, in real life. Fuck, yeah, maybe we should support different types of grass. And one of them being pink. To be honest, could do different color biomes, would look kind of nice. Fuck, that's a great idea. Man, I'm just gonna snatch that. Yeah, I think that would be... It would look very nice, and it would also add, like, variation, you know? That's a great idea. Okay. No limits, man. No limits. No limits in game dev. Okay, so this works. So what you absolutely don't want to do, what you never want to do, is this. Fuck, I need to add this as a note in my very nice issue I've got going here. Let's see, implementation notes, general implementation, vanilla terrain, normal calculation. Yeah, we're gonna do it here. General vanilla terrain generation, basic implementation in Fuck, do you want to do emoji? Do we have a dictionary? I don't like this one. Emoji Wikipedia. Warning. Don't we have a warning emoji somewhere? Could use this one. But there should exist one, a triangle one, right? What's up, Fabic? Good morning, good morning. Hope you had a nice weekend. Can I copy this one? Come on. Beautiful. Okay. Doing. Doesn't Markdown have its own? Oh, yeah, it does. I think it does. You're right. Is it warning? Oh, come on. It's the same emoji as well. Dude, nice. Warning. Doing. Mesh filter dot mesh in dot mesh dot property. I'm gonna write property here. Dot index is equal to property is extremely, I wouldn't say unoptimized, but because it's probably by design, but is, can I just say, is to be avoided. Yeah. If I want to get more information about this one later on, I'm gonna have to search for it. So let's see what we can do with vertex attribute descriptor. Yeah. So what we can do with set vertex buffer data. Let's see how unoptimized this is. So terrain patch data container. Okay, let's add a new one. I think I want to add a struct, and I'm a little bit system runtime interrupt services struct layout. Okay. Float 16 here. Although I wonder about this one. Like, could I... Okay. Let's add terrain patch data, mesh data. So here I want to do this. First of all, we want to do name space environment. Position. A little bit weird, but okay. Do they use the same? Two. Okay, sequential. Okay, but could we do? Let's be crazy for now. Like, doing it this way is very nice, actually, because if we want to save... Like, we could define... Maybe you don't want to define your position with lower precision than this. But... Like, tangent and normal, maybe? We don't care that much about those. Anyway... Layout. Okay, struct example vertex. We want to name this one to terrain patch mesh data struct. Can you have public static vertex attribute descriptor return It just feels nice to have a method here similar to this one, so that we can always make this one and this one match. so we never get a mismatch there. Or like we minimize the risk of getting a mismatch at least. So, and yeah, I want to go crazy here, so let's do, I think we can do vector 3 normal. Change this one to float 32 3. Position normal tangent, we also want a float, so vector 2 UV. Let's see, dot blend indices, blend weight. Oh, this is beautiful. Text chord 0. This is very cool. But this is all the data we have, I think. Terrain patch mesh data. So terrain patch, let's see. We want to create the mesh, we want to create the layout, we want to do vertex count, and then we want to do mesh set vertex buffer params. Then we create the vertex data. Yes, we want one of these, native array. And then set this one. Okay, let's try this. So, back to the top, we want to skip all of this. Instead, we just want one thing here. We want a private. I guess we're gonna go with native array as well. And we want to do terrain patch mesh data. Mesh data. And we want to jump down here. So here we create the mesh. Let's also create mesh data is equal to new terrain patch mesh data length. A little bit worried about this one. Let's take a look at this one as well. But I also want to do triangles, or int triangles is equal to new triangles. I think we don't need this information. I don't think we need this information either, right? We want to work with it here though. Let's keep it. Oh yeah. So yeah, we want to do this, definitely. Yeah, I don't think... Here's the question. Yeah, we're gonna do it like this. But I also wonder... Yeah, we're gonna do it like this. Let's see. Generate... let's see, what do I want to do? Yeah, we want to jump down to here, and what we want to send in here is probably mesh data, right? Or actually, that one is... We have done that one up here, so we don't need to send it in. But we're gonna do... Fabric, is that a new approach of generating mesh? Yeah, kind of. I want to see how this one works. Like we want to do, when we set mesh data, we want to do it with set vertex buffer data, I think. Because like we want to be able to alter the mesh during runtime quick, and trying to alter it by doing this was definitely not the way to go. So like when we update part of a mesh, we don't want to update all mesh data, just on a very isolated area, you know. And hopefully, I don't actually know, this is a little bit of an experimental, but hopefully doing this won't take too much time. Okay, mesh data. I'm gonna, like we do, I'm gonna assume that we can go with the same index here. So it's gonna look a little bit like this. We're gonna do mesh data index is equal to new terrain patch mesh data. Ooh. Do we need to? Yeah, whatever. Public terrain patch mesh data. Color 32 tangent. So usually this one is represented by a vector 4, so let's go crazy. Vector 4, and then we can strip it later on, because we definitely don't need float 32 to represent the tangent, or each element of the tangent, especially not the last part of it, but yeah. UV. Okay, we call it vertex here. Let's rename it. Position. So, position, normal, tangent, UV. And here we should set the mesh data instantly. I'm still a little bit worried, so for now we're gonna do... Yeah, we want to do this one as well. So mesh, new mesh, set vertex buffer. Here we do mesh data length, and on layout we do terrain mesh, or actually terrain patch mesh data dot attribute descriptor. thought. Oh yeah. Do we want to set this one first? I don't know. Okay. We set the vertex buffer parameters, we set the index format, and then we create mesh data. It's empty. We create triangles. We fill up triangles here, we fill up mesh data here. Then we set the triangles, and then we set this one. Mesh set verts mesh data. Mesh data length. Okay, so like the end result here will be pretty much exactly the same as we previously did it. So I just want to see if this one works. And then I would love to be able to do yeah, then I would love to be able to do pretty much create empty mesh data. So but fill this up with default values, and then we set the vertex buffer data in the mesh, and then we set the mesh filter to have this mesh. And then we generate the full data and call set vertex buffer data on the mesh filter mesh. Maybe it doesn't make much sense, I don't know, but like I'm currently researching the possibility to alter terrain patch data during runtime. And it being quick, basically. Okay, nice. So everything works as it did. Although, do we have? It looks pretty good. It's extremely low resolution. That's why it looks a little bit janky. Okay, so what I want to do now is basically so create the mesh, set up the buffer parameters, set up the index format, create mesh data, create the triangles, create the triangles, and then I want to do I'm worried about this one as well. Oops. And then I want to do this. Actually, we want to do, let's take this one here. And then we do the triangles. So create mesh, set it up, create mesh data, add it to mesh. Create triangles, add it to mesh. And then I actually also want to do set the mesh filter mesh, set the mesh collider mesh. And then I want to generate the data. Let's see here. what will happen here. So here we just create this one with a lot of default values. All the data is default. And here we actually generate the data. And here we set this mesh data. Do we need to do... Yeah, we probably need to call this one once again. So I want to try to do that down here. But for now, I just want to see what happens if we play now. So we should have just a plane. And we haven't set the tangent, so it should be a black plane, I think. Just a pure black plane. Or nothing at all. Because we have... Mesh must have at least 3 distinct... Okay. Yeah, that's true. So we don't even set the positions here, so it's empty. Okay, let's do... generate at index, generate base vertex data at index. I just want to try this. So index, and we're going to generate it like... We're going to keep position to be the same. Normal is just going to be vector 3.up. Tangent is going to be vector 4. Actually, and then we do this. Yeah, and I don't want this, so we're gonna do 0.0f. Okay, so what I want to try is we take this one and here. Yeah, we don't use this one here anymore. Okay, so generate base vertex data at index. Okay. So just generate done data. I want a plane to run around on. And let's comment this one out for now. Come on. Must have at least 3. Oh yeah, because we set... Yeah, we want to... Of course, we want to do... Yeah. So mesh data, and then we set it. Hopefully I'm not missing anything now. Okay, great. So just a plane. And now I want to try what happens if we do... Okay, so we set vertex buffer data, we do triangles like this, we set the mesh, and then we do mesh filter mesh, mesh collider shared mesh is equal to mesh, and then we do a lot of changes to the mesh data here, and we call mesh set vertex buffer data. So now we have assigned the mesh to the mesh filter. I want to see if set vertex buffer data like this on the mesh alters the mesh filter and mesh collider. It should, and it shouldn't take too long, right? Okay, interesting. Mesh filter gets updated by this one. Mesh collider does not. Interesting. API. Oh, come on. Okay, this is a little bit worried about this actually. Would love to be able to rely on this one, but if we need to rebuild the whole mesh, we have cooking options though. Let's see. I don't know. Okay, yeah, this is a bit unfortunate, so I guess we need to do... Every time we change just a tiny bit here, we need to set shared mesh again, and we need to recook the whole thing. That's gonna be costly, I think. Okay, that I was very optimistic just like 30 minutes ago. Now I'm a little bit more pessimistic. Yeah, we're gonna continue, but I just need to run beer back real quick. Okay, back. Sorry about that. So this is where we're at. Now we're gonna have to try it more, but I think so. We can change the mesh, the appearance, rather quickly with this approach. I do so very much like to be able to rely on a mesh collider for the ground collision detection. Worst case scenario, we're gonna have to implement a custom height map collision checker, like we did. Like we need to improve on the one we have, but like it all depends on how quick we can quote unquote cook the mesh collider during runtime. We can pass it off to, like if we get the visuals quickly, we can change the terrain visually. But the collision, I don't know. Fabic, can you do a quick test with modifying the terrain with this solution? We're gonna... We don't have any quick way of doing it right now. We're gonna implement it now, and we're actually gonna implement it, maybe not in a quick way. We're gonna implement it in such a way that we're gonna implement a terraforming implementation that is independent on, like, it's just gonna send a message to the terrain in the form of a texture, I think, so we can change between our terrain solutions and test the terraforming later on. So we want to make the terraforming generic so we can switch back and forth. But yeah, I don't know if we'll manage to do it today, but we will definitely start with the modifier implementation today. But I mean, I'm crazy impressed with the performance here on this, actually. Like, just a naive approach. I don't think this is pretty much the maximum size of the garden I had in mind, I think. I don't think we want to go much bigger than this, actually. So, like, when it comes to the terrain, this might be worst case scenario for size. Yeah, we could do a quick test, actually. Let's see what we can have. Let's see what we can do. Yeah, let's do something real quick. Let's do something like this. Terrain. Yeah, let's do terrain patch, and let's do public generate. Let's do something like this. This we can manage today. Public void alter, and let's do it by texture 2D. Brush. Okay, terrain data container. What do we have? Data here, and then we have set terrain data. Beautiful. And here we do temporary render texture, new data, read pixels. I want to check real quick terrain base, terrain data. Yeah, okay, so we want to call set terrain data, data apply. I'm not too sure about this temp here. We could probably do it on data instantly, but whatever, let's see. So for now, let's just alter the full patch and see how long that takes. So terrain patch, alter. So what we do here is terrain data dot set terrain data brush. So now we have generated the full so the full texture has changed, so we basically want to redo all of this, I think. And we don't have mesh here anymore, but instead we want to do, yeah, that's what I want to try. Mesh filter dot mesh. Set vertex buffer data, mesh data, mesh data length. Can I just do dot length? Yeah. So here we set it. So we know that the visuals of the mesh should change here. The collider does not. So unfortunately we need to do can we do so remember, this is the full mesh. Terrain base, let's do private enumerator test routine, and I return new wait for seconds, 10 maybe. What do we need to do? Oh, is it enumerable? Or? What am I missing here? System, that's not the correct one. Do I need to be specific? Unity engine dot the fuck? Enumerator. Oh, thank you. Return. What is it? Yield return. New wait for seconds. Thank you. Appreciate it. And then we do. It's been a while. Can we do float start time is equal to time dot time? No, we want to do system dot time, right? Diagnostics. Ah, beautiful. Beautiful. Oops. And we want to include this one. And instead we do okay. And here we do, let's just do it on a random terrain patch. I don't know, we can do it on the first one. So first of all, terrain data, private texture 2D terrain additional data. So here we just do, let's do terrain patches zero zero dot alter terrain test data. And then we need to start this one. Change one vertex data to see the performance hit. Yeah, definitely. Let's try. Let's just try with this first, see how it works. Then we're gonna change one specific vertex. This is, yeah. Actually, we're gonna add. Yeah, we're gonna add multiple tests here later on. But let's see. Start coroutine. What did I call it? Test routine. Okay, so 10 seconds in, we should see one of the terrain patches changing. Seconds, yeah. Okay. Let's see. Read pixels will call to read pixels from system frame, but well, not inside drawing frame. Okay, two problems here. This one, but let's see here. 39. A little bit worried about this one. Well, not inside drawing frame. This one, however, let's fix this one and see if this one is relies on this one. I don't think so, but let's see. Terrain patch mesh data has been deallocated. So I think this has to do with this one. What is it? Native array. Allocator. Alloc temp hold data for 4 frames. Oh, that's very cool. That's very cool. Let's see. So Unity collections allocator API. That's good to know. Temporary allocation. I've never worked with this before. Is this the only? But okay, Fabric, alloc temp holds data for 4 frames. I trust you, but how do you know it's 4 frames? Persistent. Persistence is probably what we want. Persistent allocation. What is with this documentation? Temporary allocation. Temporary. Unity coder was up. For the first error, could try wait for end of frame. Yeah. That should... I found it in the API documentation. Okay, nice. But let's do... I trust you. 4 frames. That's not what we want for this one. We want persistent. So let's go for persistent here, and don't have the line, I'm still in bed. Nice. Let's see, terrain patch. No, terrain base. Yeah, let's do... Yeah. Let's just do yield return null. So we wait until next frame, then we start the test. Okay, so one of the errors should be gone by now. Elapsed time, very quick, because attempting to read pixels outside of render texture bounds. Reading 00128 from... Okay, yes. Garden terrain test data is none. So let's add this one here. Okay, it was incredibly quick, but I don't know if we get the correct zero. What the fuck? Elapsed time is... I don't know. What? We do have it over here, though. But, like, what? I don't even know what that is. That's milliseconds, right? So... Is it 638 milliseconds? Fuck, I should have chosen... Let's do this test, but we do it with a mesh that is closer to our character. So let's go with... let's see, 4 times 4. Let's go with 2, 2. I want to try the collision. Oh, we do have some errors here as well. That's not good. Fuck. Ooh, yeah, we need to dispose of this one as well. What's up, modding Minecraft, still terrain? Fuck yeah. Okay, what do we have now? We don't get any change. Not allowed to access vertex data on mesh. Oh, let's see here, Fabric allocation. We need to dispose of this one later on as well. But I'm a little bit... Okay, so it worked previously, but not allowed to access vertex data on mesh combined mesh. I was wrong, were you? Let's see. Temp job hold data for 4 frames. Okay. But let's see here. Why doesn't this work? This one worked previously, but it does not work now. It's very weird. Not allowed to access vertex data on mesh. Terrain patch 190. So okay, so we need to set is readable is false. Is it mesh readable? Mesh dot is readable. Okay, how do we set it then? Mesh dot set mesh unity readable is readable. Okay. Ooh. Okay. But how do we set this one then? Is it when we create it? No. And it's weird that it worked the first time but doesn't anymore, right? Unity make mesh readable. Oh, come on. Upload mesh data. Okay. Unity set generated mesh as readable from code. Oh, come on. Why is everything... I'm still not entirely sure about this one. Not allowed to access vertex data on mesh. Combined mesh. Why did this work previously? Question mark. Is it... Is it being combined? Oh, 136. Okay, there we go. I wonder if it's being batched or anything. Very weird. Aye, no errors, and what the fuck? Is that 548? No, it's 54 milliseconds, right? And it's with the... It's with the mesh collider. Okay, let me put it this way. I want to do more tests with this. Check the performance. I want to check, like, altering a smaller area. I want to do a lot more things with this. But unfortunately, I won't have the time to do it today. But we will continue tomorrow. Because I need to run now. Fabric public void upload mesh data bool mark no longer readable. Yeah, we're gonna check onto that. We're gonna check that tomorrow. Because yeah, I need to run now. But as always, appreciate you all. Thank you so much for watching. And have a great rest of the day. Peace.